Welcome. This is Dr. Gary Salton, Chief of R&D and Creator of IOP Technology. This study focuses on women in engineering leadership. Prior research has found that men and women engineers differ significantly in how they approach decision issues. This research seeks to determine if that difference extends into management. Information processing is used as our analytical lens. The underlying idea is that information available determines the kind of behaviors that are possible. For example, details are required for reliability and precision. Without detail, precise, dependable execution is not possible. If you would like to know more about how IOP works, this 8-minute video provides an overview of the IOP styles and patterns used to measure information-based strategies. Those measures were applied to 543 women and 2,771 men in the sample used in this study. All are working engineers at various hierarchical levels in multiple organizations. To be fair, there are some thin categories. Statistical tools are available to handle small samples, but it is probably wise to look at our results as indicative rather than as definitive. Strategic styles are IOP's short-range tool set. There are 4 basic styles, each of which can range in strength from essentially 0 to 100%. Styles are a person's most likely out-of-the-box response. It is their first inclination in addressing a new issue. These are the style strength differences between men and women at various levels of engineering management. The variation is not a surprise. There is random fluctuation in almost any sample of anything. So, we use statistical significance tests to signal which of these variations are real. The label NS indicates an insignificant variation. There is more than a 5% probability that these are just random fluctuations. And we found that none of the differences at the managerial levels register even a marginal level of significance. This means that those women who have been admitted to the managerial ranks did so on the same terms as their male counterparts. No one got any special breaks or penalties in terms of their approach to decision making. But the story changes at the professional level. Here, there are highly significant differences in 2 style categories. A greater proportion of women engineers rely on the disciplined procedures of the LP strategy to navigate life, and they put less stock in the idea-generating RI style. This finding has consequence. IOP styles are a signal for promotional suitability. They can determine if a person even gets considered for a promotion in the managerial ranks. For example, professionals inclined to react quickly using minimal information, that is the RS style, are unlikely to be considered as a project manager for a nuclear reactor job. Each of the other IOP styles carries similar behavioral preferences. These qualities come to be used as the first screen in the promotional process. In engineering, there are proportionately more women in the professional ranks whose style is ill-suited to management. These women are screened from promotional consideration. The smaller proportion of women whose decision styles are well-aligned are considered and thus have a better chance of passing through that screening for hierarchical advancement. And data tells us that the advancement screen has a pretty tight mesh. The Bureau of Labor Statistics reports that women make up 43.7% of the population in business and finance, and occupy 38.6% of its managerial positions. That's a shortfall of roughly 12%. In engineering, women make up 15.4% of the workforce, and hold only 7.6% of the managerial positions. That's a shortfall of 51%. And this shortfall is at least partially attributable to the difference in style election among women who enter and are prepared to remain in the engineering profession. This has some implications for style equity initiatives. Gender is more obvious than style. Blaming the shortfall condition on gender discrimination can lead to focusing on the wrong people for the wrong thing and prescribing the wrong remedies. It is a formula for flailing initiatives and frustrating outcomes. And that is not the end of the story. Most engineering efforts involve a series of decisions as an issue moves from inception to conclusion. The output of one decision becomes the input of the next. No single style will apply to every decision all of the time. When the style doesn't apply, people shift to their next most favored style. Since style preferences tend to be stable, the pattern of their use is also stable. IOP terms these favored style combinations strategic patterns that can be grouped into these four basic categories. Strategic styles are what gets you noticed for promotional consideration. Patterns are used to assess your probable performance in that managerial role. And here are the percent differences in strategic patterns between men and women in the various managerial categories. And once again, significance tests are used to figure out if these differences between men and women are just random variations. Only 2 patterns in the managerial ranks are outside the bounds of chance variation. The man-woman difference in project management is based on a small sample and registers only a very marginal level of significance. It is probably unwise to assign a lot of importance to this finding. The man-woman difference in the mid-level management category is more substantial, but still marginal. The difference may be real, but it affects only one of the 4 patterns. The confined character of this difference does not bespeak of a widespread bias on this dimension. On the whole, women appear to be in engineering management on about the same terms as are the men. The story is different at the professional level. Here, women differ from men on all 4 of the IOP information processing pattern dimensions. 3 of these differences are highly significant. There is less than 1 in 1,000 chance that the difference in these 3 areas are just random variation. And this has implications. The pool of women from which management can be drawn is first disproportionately diminished by their style elections. Now the difference in pattern choices disproportionately affects women once again. This finding suggests that the root cause of gender inequality in engineering is not exclusively gender. It is at least partially attributable to the information processing elections of those women who choose to enter and to stay in engineering. But the natural inclination is to blame the obvious. And since it is obvious that women are not getting their fair share of management positions, it must be due to gender discrimination. What is not seen is that men engineers who share the dominant style and pattern preferences of those disadvantaged women are equally disadvantaged. There are just proportionately fewer of them. There is undoubtedly an element of gender discrimination in engineering. But the information processing elections of women who choose to enter and remain in engineering is also an issue that has to be addressed if gender equality is to be attained. The Women in Engineering study provided some ideas on how this might be accomplished. Better policies and processes will go a long way toward helping to meet this goal. Increasing the number of women in engineering will also help. Some portion of that increase will stay, and just the raw increase in numbers will improve equity ratios and help introduce norms and standards favorable to women. However, our Engineering Insight study identified the root cause of the engineering culture. That cause is the societal demand for predictability. Society wants buildings that stand, cars that start, and pliers that grip. The engineering culture is designed to produce that result. Any initiative targeted at improving women's participation in management will need to preserve that cultural element. The nature of interactions must change without changing the outcome of those relationships. There is no universal formula for achieving this goal. The solutions will be local and will require local initiatives. and therein lies the challenge. In many other professions, people at the various levels of management subscribe to somewhat different strategic style and pattern preferences. For women, this provides an opportunity to have their concerns addressed by people who might be better able to see an issue from their point of view. This is not the case in engineering. The Engineering Insight Study showed that from the chief engineer down, engineering management tends to see the world in the same light. The same variables are always relevant, the same weight is given to them, and the same character of outcome is targeted. This limits the number of relief valves to which women might have access. However, there is a key to this latch. The vice presidential ranks are populated by people with high levels of idea-generating RI-style capabilities. The Engineering Insight Study showed that there was only one statistically significant difference between engineering VPs and VPs in the other professions. The engineering VPs' RI capabilities exceeded those other VPs by 15%. This means that engineering VPs are differentially better equipped to generate new out-of-the-box options on almost any subject. This capacity can be directed toward norms, processes, and procedures that preserve the basic engineering culture while simultaneously leveraging the talent that women bring to the profession. And the VPs have the resources and authority to implement those ideas. But to get the key into the lock means that the VP must reach down and take an active interest in recruiting at the professional level, and then actively guiding the practices at the various hierarchical levels to help ensure that those women who enter are nurtured and retained, with particular attention given to those women whose posture is aligned with the demands of engineering management. Engineering is a broad function with reach into a host of different industries, each with different missions, different technologies, different hierarchical structures, different mixes of people who hold different degrees of commitment to the various IOP styles. There is no cookbook prescription on exactly how a VP should go about meeting the challenge of women's participation. However, getting the VP's active acceptance of this challenge is probably enough to effect a change. Harnessing the average engineering VP's strong RI capacity is likely to ensure that there will be no shortage of potential remedies. These remedies will be local, but cumulatively will organically alter the engineering culture in a way that preserves its advantages, while vastly expanding its intellectual and operational capacities as the goal of women's participation is increasingly realized. This research does not offer a replacement for the many other initiatives currently underway. It adds to them by offering a measurable variable that can be used as a metric for both attracting and retaining women at all levels of engineering. It also offers a tool to help structure the profession in a way that facilitates their incorporation while preserving the core engineering culture. It is worth a serious look. Thank you for viewing this video. If you would like to learn more about IOP technology, please visit our websites at iop.com or oeinstitute.org. Both sites have much more information on IOP and the areas where it has or can be applied. Thank you again for your interest in IOP technology.